Most people think a rocket launch begins at the launch pad. In reality, it begins years earlier inside factories, engineering offices, testing laboratories, software centers, machine shops, and supply chains spread across entire countries. Before a single bolt is tightened onto a rocket, thousands of engineers and hundreds of companies have already contributed materials, components, software, manufacturing expertise, and infrastructure. Composite manufacturers build lightweight structures. Electronics companies produce flight computers. Precision machining firms manufacture critical engine components. Testing facilities validate every part. Logistics companies move oversized hardware across vast distances. What appears to be a single rocket is actually the result of a massive industrial ecosystem. The launch vehicle is simply the final product of a hidden network of suppliers, engineers, manufacturers, and specialists working together toward one objective: reaching space. Although these companies may be separated by hundreds or thousands of miles, they all contribute to the same mission. Raw materials become components. Components become subsystems. Subsystems become complete assemblies. Every valve, sensor, circuit board, fuel line, software module, structural frame, and communication system eventually moves toward a common destination. The launch site becomes the meeting point of an enormous industrial supply chain. Every truck delivery, every manufacturing milestone, every quality inspection, and every engineering review pushes the project one step closer to launch day. What makes spaceflight remarkable is not simply the rocket itself. It is the coordination of thousands of activities that must occur perfectly across hundreds of organizations before the countdown can even begin. The rocket is where the entire industrial ecosystem finally comes together. Hundreds of companies may contribute individual parts, but all of those parts eventually become one machine. Every section of the vehicle represents years of engineering development, testing, certification, and manufacturing. The rocket stands as a physical representation of industrial collaboration on a massive scale. Aerospace engineers, materials scientists, software developers, electronics specialists, manufacturing technicians, logistics coordinators, and quality inspectors all contribute to its creation. When people watch a launch, they see one vehicle lifting from the ground. What they do not see are the thousands of people and companies whose work is embodied within every meter of that rocket. A rocket is not a single machine. It is a collection of interconnected systems that must function together with extraordinary precision. Propulsion systems generate thrust. Structural systems support enormous loads. Avionics systems provide guidance and control. Communication systems transmit data. Thermal systems manage extreme temperatures. Power systems distribute energy throughout the vehicle. Payload systems protect valuable cargo. Each system depends on the others. A failure in one area can affect the entire mission. This interconnected architecture is what makes modern rockets among the most complex engineering systems ever created. Every launch depends on thousands of components operating together as a single integrated machine. At the heart of every launch vehicle is the rocket engine. This machine converts stored chemical energy into thrust powerful enough to overcome Earth's gravity. The engine must operate under some of the most extreme conditions found anywhere in engineering. Temperatures can exceed several thousand degrees Celsius, while internal pressures reach extraordinary levels. Despite these conditions, the engine must perform flawlessly. Every launch, every mission, and every payload depends on its reliability. The rocket engine represents decades of engineering knowledge compressed into a single machine. Without it, none of the surrounding infrastructure matters. The engine is the device that ultimately transforms a vehicle sitting on Earth into a vehicle traveling through space. Hidden inside the engine is a machine that many engineers consider even more impressive than the engine itself. The turbopump is responsible for moving enormous quantities of propellant at extremely high pressures. It spins at astonishing speeds while handling cryogenic fluids colder than Antarctica and gases hotter than a furnace. Without the turbopump, fuel and oxidizer could never reach the combustion chamber in sufficient quantities. The engine would simply stop producing thrust. Although few people have heard of it, the turbopump is one of the most critical machines in aerospace engineering. Entire rocket programs have succeeded or failed based on the performance of this remarkable component. Every rocket engine depends on a carefully controlled flow of propellants. The fuel system acts like the circulatory system of the rocket, transporting liquid hydrogen, methane, kerosene, or other fuels alongside oxidizers such as liquid oxygen. Valves regulate flow rates. Sensors monitor pressure and temperature. Filters remove contaminants. Control systems adjust performance in real time. Every drop of propellant must arrive at exactly the right location, pressure, and timing. A minor deviation can reduce performance or threaten the mission. The fuel system may appear to be a collection of pipes and valves, but in reality it is a highly sophisticated network responsible for delivering the energy that powers the vehicle into orbit. This is where the magic happens. Inside the combustion chamber, fuel and oxidizer mix together and release enormous amounts of energy. Temperatures rise to levels capable of melting many metals. Pressures build to extraordinary levels. Yet the chamber must survive these conditions repeatedly and reliably. Engineers use advanced cooling systems to protect the chamber walls while maintaining structural integrity. The combustion chamber transforms chemical energy into high-energy gases that are accelerated through the nozzle to generate thrust. Every launch depends on this process occurring perfectly. It is one of the most extreme environments ever created by human engineering. While the engine provides power, the avionics system provides intelligence. Thousands of calculations occur every second during flight. Flight computers process data from sensors throughout the vehicle. Navigation systems determine position and orientation. Guidance algorithms continuously adjust the flight path. Communication systems transmit information to mission control. Without these systems, a rocket would simply be a powerful engine without direction. Avionics transform raw power into controlled flight. They ensure the vehicle reaches the correct altitude, trajectory, and destination. In many ways, these systems function as the brain of the rocket, making critical decisions throughout the mission. The rocket receives most of the attention, but the launch would be impossible without the infrastructure surrounding it. The launch pad provides structural support. Cryogenic storage systems hold propellants at extremely low temperatures. Power systems distribute electricity throughout the facility. Communication networks connect engineers, computers, and monitoring systems. Water deluge systems protect the launch pad from intense heat and acoustic energy. Safety systems monitor every stage of the countdown. Mission control coordinates thousands of activities. The launch site itself is a complex engineering project that rivals many industrial facilities in scale and sophistication. Every successful launch depends on this hidden infrastructure working perfectly. A rocket launch is far more than a rocket. It is the result of hundreds of companies, thousands of engineers, and countless machines working together through an interconnected industrial ecosystem. The same hidden complexity exists throughout hydrogen production, fuel cells, compressors, electrolyzers, data centers, industrial water systems, power generation facilities, and advanced manufacturing plants. Understanding these systems begins with understanding how the machines connect. If you want to explore the engineering behind the world's most important infrastructure, visit H2 Hub by ReneEnergy, generate hydrogen project schematics, explore engineering systems, and discover the hidden machines that power modern civilization. Visit h2hub.reneenergy.com to continue the journey.